Good evening, friends. This is question number 3.2 from the chapter NCERT, and the chapter is chemical kinetics. So, in this chapter, let's reduce the size. Yes. The rate constant for the decomposition of N2O5 of the various temperature is given below. That is when temperature 0 degree Celsius, 20 degree Celsius, and 40 degree Celsius, 60 degree Celsius, and 80 degree Celsius. So, this is the temperature. And at that time, the rate constant is into 10 raised to power 5 is 0.07, 0.0787, 1.70, 2.25, 25.7, 178, and 21.40. This is a value of K. So what we have to here calculate. So first, draw the graph between ln K and 1 by T and calculate the value of A and EA. Okay, and predict the rate constant at 30 degree and 50 degree. This is too long question, but we will try to solve it more rapidly. So according to Arrhenius equation, that is a K is equal to A into e raised to power minus EA by T by taking the natural log. This is the ln of K, that is the ln A minus EA by R upon 1 by T. So here EA is the activation energy and T is the temperature, R is the normally gas constant. So this is the form of y is equal to mx plus c as you study in your classroom. So here is y is basically ln of K, x is 1 by T, c is basically cross section, that is ln A, and slope m is minus EA by R. So first step is what? Calculate ln of K and 1 by T, because we have to make the graph between natural log of K and 1 by T. So put the value of, this is a temperature in degree Celsius, that is 0, 20, 50 and 80 according to the question. Now convert it into the Kelvin. So what we do for the conversion in Kelvin, just add 273. So if you have degree Celsius plus 273, and this will become into Kelvin. So I hope this is, you know, all better. So this is the value in Kelvin. So next is value of K, as it is question in given 0.0787, 1.70, 25.7, 178 and 41, 21.40. So now it calculate log just K. So K is what? It is a basically 0. Just like example, this is a 0.0787 into 10 raised to power minus 5. This is the value of K. Okay, and when we manage the decimal, so this becomes 7.87 into 10 raised to power minus 7. Okay, so this is the all value of K in per second. There is a unit in per second, that means this is the first order reaction. Now time to calculate ln of K. So how do we calculate ln of K? We use generally log table. First it convert into log. So if we take the log of this, suppose log 7.87 into 10 raised to power minus 7. So what we calculate the value of which comes, it is basically the value of logs. But we need what? Ln of K. So just multiply 2.303 and it get converted into ln of K. So the value of first is minus 14.06, this, and then minus 11.98, minus 8.26, minus 6.63, 33, and then minus 3.85. Now calculate 1 by T. As we know, T is this. So basically what we do 1 by 273 like first condition, then 1 by 293, and when we solve it, then we becomes the value of 1 by T. So this is 1 by T, and we convert into 10 raised to power 3. So this is basically 3.63, this is 3.1, 3.0 and 2. This is the value of T. So just plot the graph. In y-axis we plot ln of K, and in x-axis we place the temperature. So temperature as a given question, that is a 2.6 into 10 raised to power 3, 2.8, and like this value is basically shown here. And in this side we have the value of what? We have the value of ln of K as be given. So when temperature is this, the value of this point, so we just meet and find the point and make a straight line. This is a straight line graph with the intercept of ln A. So the first condition is solved, that is a graph between ln of K and 1 by T. Now second is, so this is basically about the plot. Now calculation of EA and A. This is also we calculate from the graph. So from the graph, that is a best line fit, that is a m is equal to minus EA by RT, and the value is becomes minus 1.21 into 10 raised to power 4. You can easily calculate here y2 minus y1 and x2 minus x1. Take any point from the graph. This, how to it obtain? This is obtained y2 minus y1 upon x2 minus x1. Then we get this value. So as we know, so what is the EA? So EA is equal to minus m by r by this formula. So m is basically this point, and r is basically 8.314 as we know. So on the calculation of this value, this becomes 1.103 kg per mole. So activation energy is obtained this. So activation energy calculated. Now second term is predict the rate constant. And what is the A? So A is basically what? Ln of A. This intercept is basically what? ln of a. So we can easily find ln of a. And how to solve ln of a? Convert into it log base 10 and then take antilog and you solve easily. Or we can say you can calculate e raised to the power something. So this value is basically 35.50. This is into e raised to the power. So this value becomes a is a 1.07 into 10 raised to the power 14 per second. Now predict the rate constant at 30 degree and 50 degree. You can also use this formula, ln of k is equal to minus 8 and k is equal to this, or we can also solve using this formula, ln k is equal to ln of a minus ea by r and 1 by t. So you can easily calculate here ln of k, then you can convert it to ln of k into log base 10, and then you take easily anti-log of it, because you know a, r, ea and t, everything is you know. We can also solve by using this formula. So I hope this question are very important and you all are